Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Let's get started. It's Tech Talk time with Mr. Carlson. So grab yourself a coffee, or whatever beverage you prefer, and a snack, sit back. You can listen to me ramble about some of the projects on my bench. So I'm thinking of starting another series here, and it's basically just a Tech Talk series about whatever's on the bench at the time. Normally, you know that my videos are very thorough and they start at the beginning of a restoration, go all the way through right to the end, or same with a repair, we'll start right at the beginning, go all the way through, and then end. And those videos take a lot of time to put together, an incredible amount of time. Some of the videos take a month or so to make. So a lot of stuff comes onto the bench and a lot of stuff leaves the bench in that time, and I usually don't share it because there really is no set process for this stuff. So for example, as you see here, there's a bunch of meters on the bench here. I'll work on these, and something that will take priority will come. I'll remember where I am in this particular piece of equipment, put this off to the side, work on the piece that requires priority, and then once that's done, put this back on and carry on with this. And this is kind of the shuffle that continually happens here. Now, this shuffle is the reason that I don't put out a lot of videos, because there's just so much movement, and whenever I share videos with you, I usually want it to have this logical process from the beginning to the end. The problem with that is I don't share a lot of videos just because of that logical process. So I figure with this Tech Talk series that I'm going to try here, what I can do is I'll just be working on pieces, and I'll share with you where I am at the particular time, and any hints and tips and tricks as I'm working on this type of equipment I'll share with you, and maybe you can get some information out of it this way as well. And this allows me to get more videos up so you can spend more time with me in the lab. So you can let me know if you are interested in that, what you think of that down below in the comments. And so that's where I am right now. So the project that's on the bench is 2 meters here. And again, for my repairs and restoration videos, sometimes I do a picture-in-picture. Okay, so if I'm testing something, it's handy to have, say, the meter up in this corner here of the video, and you can see the meter as I'm testing things. And we can see a bunch of things at the same time. So you can see me, moving an IF transformer. You can see the meter move up here, something like that, right? Whatever. So I have these, LCD and, VFD meters, the standard kind of, ho-hum kind of meters. And I figure, well, why not have a neat looking meter up in the corner that we can all look at the same time? So that brings me to these HP meters. Just move my coffee out of the way here. Crust doesn't fall on my coffee, and I get to drink old HP meter crust. So I got these old meters here, and I have one that's just off to the side right here that's on right now. And I've had this one for a while. These ones here were, I guess you could say deemed parts units. But this is just something that's like maybe sticker residue, and same here. So that looks like it could be cleaned up very well. Now, I want to use this particular meter because it has 5 nixies in it. 4 in reality. This 5th one here is a plus and a minus symbol. So it's neater than this meter off to the side, which I was considering using. So you can see I've got a bunch of cards out of this thing, and with the nixies on. I'll talk about those here in a moment. I'll explain about the logic and all that as well. So I'll move this out of the way, and I'll just move this other one into the shot here. So I just recently kind of twiddled it to perfection, I guess you could say. Problem is movement. Move that onto the floor, heavy. That was the handle going snap. The handle went snap like that. So the thing is with these older meters is they're very picky with temperature. And whenever you're doing an alignment on something like this, there is a very, I guess you could say, what would the word be? A very critical process. Well, first of all, what you do is you plug something like this in. So right now it's measuring 8 volts from my standard, which is up in the corner here, and I'll get another camera on that in a moment and put it up in the corner here. So just me moving this around and getting some airflow in here will cause this to move, this last digit here to move. They're very, very sensitive to temperature, these early units. So, and that can all be calibrated on this card and back in here and things like that. So the reference, internal reference is steady at 8. Right, you can see it's flashing 1 there, and then when I let go, it's 8001. And you can see because I'm moving it and I've got this not laying on here, the temperature is starting to change in here, and that airflow is causing this to decalibrate. So now, whenever you're calibrating an older HP meter like this, this is all discrete, right? It's all just transistors and resistors and capacitors and such. You see all the micas and everything in here. whenever you're calibrating something like this, you want the bottom pan on this thing to begin with. So you'd want to have the bottom pan on, and then on the top side, you would want something like this, the lid on it. And then what you would do is you put this on and just let it sit loose like this. You don't need to screw it down, but you let it sit loose for about half an hour to 45 minutes. And if you really want a nice cal, you're going to go for an hour or so. Let the thing sit for an hour and let it come up to temperature. And then what you're doing after that point is you're, moving this thing back and lifting this up. And then you're going to move the points that you need to calibrate very quickly. Put this back on again and let it sit. And make sure everything is all stable. And then if something moves, you get familiar with the calibration points and you go back in, and then you'll twiddle the part that you need and put the lid back on, and eventually you'll achieve, I should say, a pretty good alignment with these things. Now again, they're temperature sensitive, right? So it has to be done like that. And this is, I guess, very common for this older type of equipment. So it's moved up, not very much. So from 8 volts to 8.002. So that's still pretty good. Now I could probably zero this out and give you an example of this thing here. So I'll let this sit down so it doesn't get too incredibly far. And I'll give you an example of the accuracy of this old HP meter. So this one here is, the reason I don't want to use this one, you can see the plus and the minus here are just neon lit kind of, it's a sectioned off piece of plastic, or I think this is even bakelite, a sectioned off piece of bakelite, and there's just a neon bulb behind a plus and a minus symbol, whereas the other unit with the Nixies is, I think this is one of them here. It is, yeah, there's a plus and a minus in this card. So what's really interesting about this is this thing is, when they gettered these Nixie tubes here, I guess it must have flashed onto the face a little bit, and there's a bit of a darker spot in the center. Now a lot of you might be thinking, that might be from use. Well, no, not really. I have some of these brand new in a box that are like that, so you kind of have to look through a bit of a dark spot. These ones here are kind of excessive. This could be a combination of both, maybe some usage and a bit of gettering getting on there. It's kind of odd. It's only these ones with the normal Nixies. All the other Nixies in these units are just perfectly clear, right? So bizarre. At any rate, so for the other unit with the Nixie that's got the plus and the minus symbol in it, I have to scavenge through a bunch of Nixies to get one that's clear, because when you put the camera on it, it's kind of have to either look down or from the side, because a dark spot kind of obscures it. But more Nixies is better, right? So that's the reason I wanted to get that other meter working. Now I've got a whole bunch of plugins here as well. This one here is a high gain version. This is a high gain auto range unit. And I've got all sorts of different plugins for these things. This one is just a DC plugin, and it's an automatic range selector as well. Not the high gain version, but it's an auto range selector. And because I'm doing this calibration on this thing, there's a pot for hysteresis down here. And that's it. So there's basically no cal in the plugin, so I can just leave this alone. I don't need to worry about that right now, and then just cal what's in the meter. So that's the reason I have this in here right now. And this old unit is surprisingly accurate. It's like incredibly accurate when it's caled, and when everything's to perfect temp. It's very, very good for what it is. So that's what I'm doing right now. Now in these units here, this is before they had really high voltage transistors happening, okay? And what they would do is they have a series of neon bulbs and photocells under this block here, and different combinations of neon bulbs will glow. The logic for these old HP units isn't 1, 2, 4, 8, 16, 32, 64. It's not like that, like the logic that we have now. The logic in this is 1, 2, 2, 4. And it's a little bit different. And I believe they had an option for these things to make it, standard 1, 2, 4, 8, right? So interesting at any rate. So that's what's happening with these things. It has a different logic in here, but once you're used to it, you only really need 1, 2, 2, 4 for this, right? Because it's 0 to 9. It's not doing any letters in the alphabet or anything like that. See, since I have this thing laying here, because the bottom's open, right? Since I have this thing laying down, it's gone back to 1 again. So it's starting to warm up again. So you might be saying to yourself, that's way too finicky to be using and everything. Well, no, if the covers are on it and you let the thing sit for half an hour, you turn the thing on and just let it sit, you're absolutely fine. A lot of people nowadays think that everything has to be, working and up to temp and to spec within 2 minutes or the minute you turn it on. It's not like that with any type of test equipment. My Fluke 5440B, that's right up here, which you'll see in a moment as I'm moving the numbers around here, you'll see that thing has to warm up for half an hour, or if you run a self-diagnostic on it, it'll give you all sorts of horrible errors. And there's a lot of circuitry in there. So I've had it apart already, and lots of relays to clean. In fact, I did that 1 week ago. It was giving me all sorts of errors. So gain calibration errors and all sorts of things. So at any rate, so everything has to warm up. That's the way it is, especially in test equipment land. Things with standards in them have to temperature stabilize. Now, of course, this is much. Let's look at that. Back to zeros again. So if I keep this down like this, it'll do that. But I'm gonna have to tip it up, so you're gonna see it move around here a little bit. But at any rate, so all this stuff, it needs to temperature stabilize. Now, of course, this particular unit like this with Nixies in, it's got high voltage in it. And, it's very easy to come across. If these capacitors weren't shielded, that would be horrible to come across those caps, because this is, positive and negative 150 volts for this unit to run the Nixies. And this here's a lower voltage supply, about 40 some odd volts is across that cap. So, whenever you're working on something like this, you always have to keep that in mind. These things are, loaded with high voltage. And this is before they, covered, we're very specific about covering mains. Like, you've got filter blocks all over the place in this thing, and, that are just exposed mains, things like that. It's the way things were made. When technicians were going, oh, okay, well, there's the mains, I'm not going to touch that. It seems like nowadays that kind of knowledge is a little bit forgotten. Okay, so what I'll do here is I'll set up another camera and I'll get it onto the standard here, and I'll give you an example of how accurate this little thing is, and then we'll take a look at the other one. I'll plug it in and see if we can make the thing live, see if it even fires up. I have it on the desk here, and I turned it on briefly, and it really didn't cooperate too much, but I'll turn it back on and we'll take a look at it together and see what's going on. So give me a moment and I'll set up another camera. Alright, I'll try to give you a quick example of the accuracy of this thing when it's open. At any rate, you're going to notice this digit's going to probably move because the temp is changing. The bottom and the top are both off right now. Alright, so if you take a look in this upper corner up here, you'll see the standard is up there, and it's at 8 volts right now, and that's reading this 8 volts right here. So what I'll do now is I'll go to 80 volts. So I'll go 80, yes, and it'll go into standby, and I'll have to turn this back on. That's 80 volts right there. All right, so now let's go to 800 volts. Pretty good. Not bad accuracy for this old machine, right? So let's try 1.5 volts. So let's go, I'll just shut this off. 1.5 here, and I'll turn this back on again. Not bad. Not bad at all. So, as expected, this is going to creep up a little bit because this is all open right now and it's tipped up. So I'll just shut this off and we'll see if we're back at 8. So it's probably 8.001 now. So I'll go 8. Yes. Operate. Yeah, not too bad. Not too bad at all. Still holding 8. Let's see what the reference is. It's at 8 as well. So it's right on the verge. So 1.501 wasn't too bad. Again, when it's all together, it'll hold that. I can go 1, 2, 3, 4, and it'll say 1, 2, 3, 4 on here. So we'll go, let's go, for example, let's try that again. So what was it, 1.5? 1.5, enter. There it is. Now, it's right on the verge. So not bad. So let's go 1.23. So 1.23. 3, enter. You see, not bad at all. Now keep in mind this is 1968 technology, right? And again, if it's temperature stabilized and perfectly aligned, that will be 1230, and it'll stay steady on the 0. The fact that, you know, like I can go say, we'll go say 80 volts again here. Enter, and it'll shut me off. I'll turn that back on again. And it sits at 80 like that, and it's not, you know, 81 or, you know, 79.99 is very impressive for this old machine. And of course it's auto ranging. That clicking you hear is the relays in here that are moving around. So if I go up to 800 again, hear things click. I don't know if you heard that click in there. So 800. Let's try 875, just random numbers. 875. Pretty good, you know, not bad at all. So, and again, you know, it's just wide open. So just shut this off. So when it's doing a test like that, you know, being close to these things is, you know, you definitely want to make sure the 5440p is in standby before you go handling anything like this, especially with that kind of voltage across it. And in fact, what I'm going to do is just change this down to 8 volts and just let it sit there just in case I was to accidentally touch anything here, and turn it back on. I don't want 875 volts on this. So there you go. You have a pretty good idea of the accuracy of this unit here. Now the other one is, I don't know if you could say more desirable. I'll shut this thing off, and what I'll do is I'll just move this. So what I'm going to do is take this off first, this off second, and this off third. Get out of here. I'll move this out of the way and put this under the bench. Get this other one up here. So this one here has a few perks on this. So this one here, all that scratching and dust and everything that'll definitely need to be cleaned up. I was kind of blurred out there. This has got a variable sample rate, so you can turn this on and it'll get fast, or, you know, slow. You can slow this rate down. So actually the hold is on this side, so this would be, you know, I guess the slowest sample rate, and then this would be the fastest. Now it's got a faster sample rate than the other one, and of course, you know, we're displaying on the Nixie here the plus and the minus, so we have one extra Nixie. So I figured this one would be the neater unit to have. Unfortunately, this looks like it's going to be a lot of work. So what I'm going to do here is, let's see, do I have all the cards in here? I do. So what I'll do is I'll grab that other plug-in out of the other unit, and I'll slide that plug in here, and we'll turn the thing on and see what it does. I don't think it's very cooperative, but I'll be right back. All right, I put the 3442 plug-in in here, and this thing here, it emits a smell if it's left on for too long, so that's not a good thing, but I can turn it on enough to give you an example of the display with the little Nixie here with the plus and the minus in it. So you see that? That's not bad. So that's what the little minus looks like. Of course, it's a little bit blown out right now because of the exposure, but anyways. So I think the Nixie with the plus and the minus is much nicer than the other. Just kind of a, you know, a film over a neon bulb type of digit kind of thing they've done in that. It's the same as this, right? It's a neon bulb behind the actual just like written stuff. So call me crazy. I think that looks better. Anyways, the sample rate here is much faster on this unit, and it's variable, as you can see. So the sample rate on the other one is fixed at about that speed rate there. As you can see, this one's got a much faster sample rate, and that's really nice. I like that much better. So that's another reason to have this thing. I'm not smelling it yet, so that's a good thing. Leave it on for a few moments. So the display on this is really nice. The window's really scratched up. I'll have to, you know, clean the window up in this unit and, you know, clean the whole thing up. Take all the cards out and maybe replace some of the resistors on the cards in here. There's some of the resistors they like to go bad in this. So I wonder if I can spot what's getting hot. I'll just turn this on here, my little flare, and I'll just look around. You can see a bunch of resistors here that are getting nice and warm. And this capacitor here is getting warm. That's probably what's doing it. What I'll do is I'll put this into the shot like so. And move this over here and see if I can you an example of that. Where are we here? There it is. I don't know if that's gonna... See that? This is that cap right here. See it glowing? It's getting nice and warm. This is the cap that's in front of it, right? This one right here, not a problem. This here is the cap. That's the transistor in the back there. So as you can see, kind of hard to see in this. But anyways, that cap is getting nice and warm. So that's probably what's causing the problems. Yes, it's definitely getting warm. So I'll just shut this thing off. And the power supply for that is on this board here. That smells probably a carbon composition resistor. So what I'll do, let's check this out together. So I'll just make sure the capacitors are discharged safely. Disconnect this from the supply and use my capacitor discharger here to make sure that these are all... One of these LEDs will flash if it's got a charge on it, and it doesn't look like they do. No, everything is okay. So I know I'm safe. These are very important to have discharged because these are the positive and negative 150 volt supply. So you're dealing with 300 volts between the two. So it's always safe to discharge them. This is one of the projects that I've designed and released on Patreon. So if you're interested in building a safe capacitor discharger for working on all sorts of different equipment, this is the device to have. And it has carry-through leads as well. I'll just grab the carry-through leads. Everything is tangled up here. These are the carry-through leads here that can be plugged into a standard, voltmeter or whatever. And so if you don't want to rely on the LEDs alone, you can actually watch the voltage fall on a voltmeter as well. So all the plans to build this and the diagrams and everything are all up on Patreon if you're interested in that. For those of you that are new here, that's what I do. I design circuits and release them on Patreon. I've released many inventions and all that kind of stuff on Patreon to all the people up there. So lots of really neat projects. If you like learning through building projects, it's the place for you to be. So it's an ongoing electronics course. At any rate, so this here is the power supply board. And just so you know, these are all low voltage caps. I'm not really too worried about that. And I'll get some light on the situation here. Maybe zoom on into this so that we can have a closer look. Look at that. And that's looking pretty charred. So that's one of them there. And this one is looking discolored as well. You can see the color of the first band. It's 100 ohms, right? The color of the first band is nice. And then this one is dark. And then same with this one here. This one is actually charred. The dark band in the center here is 100 ohms, so that black band is actually blending in with the body. It's blending in, so this one is really charged. So this is probably the one that's attached to this little fella here that's getting nice and hot. So all those need to be changed out. Now in the other meter, I tested those for leakage years ago, and they've been absolutely fine. Look at this, right? You can tell it's definitely time. So anyways, in the other meter, I changed out a whole bunch of the caps on these boards, but I tested these all for leakage years and years and years ago, and they all passed with flying colors. Now, of course, this one here looks like, I think this thing was destined for the bin when I got it. So as you can see, it's looking pretty rough. So, and of course, I have two more of these for parts. One, the handle's completely broken right off. And some of them are bent and, all just, these things have been really, it looks like they've been tossed around. So I think these things were all intended just to, be scrapped. So it's nice that this one here is not going to get scrapped and it's going to be brought back to life, cleaned up, and it'll be used as the picture-in-picture voltmeter here on Mr. Carlson's lab. So when I'm doing restorations and repairs, we'll have a nice Nixie kind of meter at the top here, and I'll use that for testing. So there you go. So if you're interested in seeing me do the entire alignment on this thing and going through this, you can let me know in the comments below, and maybe in another tech talk video or something like that. What we'll do is do this all together. Go through all the alignment points and maybe align this up, and I'll show you how to, I guess you could say, take note of all the warm-up precautions and things like that. I'll show you how I do that. And I'll show you my procedure for aligning this test equipment. So it's a little bit of a trick with these things, but Lots of alignment points, 1000-volt alignment, 100-volt alignment point here is comparator adjustments, 8000 reference here, ramp adjustment over here. On the other boards, the 35-volt adjustment and the oscillator adjustment here. See that there, negative 35s, and the oscillator adjustment right over here. So all sorts of things. They've kind of mixed everything all together in these things. I remember this all from doing the other one years ago. I spent a lot of time doing the alignment on the other unit, and that's why it turned out like that. And I changed, you know, a whole bunch of components to make it relatively accurate again. So anyways, there you have it. If you enjoyed, let me know. And in the next Tech Talk video, we'll do this. And if you have any ideas for other types of Tech Talk videos, let me know in the comments. I will consider them. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you'd like to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the Show More tab below the video's description, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.